Welcome back. The rosette is the simplest algorithm in the application. The function is passed an integer. It cycles through 6, 12, and 20. Let's focus on 6. The outer perimeter is a hexagon. 6 points are distributed equally around 360 degrees. Each outer point is connected to every other outer point. In other words, it's a complete graph. Let's take a look at the code. The function creates an empty array of points. It calculates a radial distance, which is based on 2 pi radians divided by the number of perimeter points. Now, in Swift, n is converted to a double because it does not provide a binary operator for dividing a floating point number by an integer, unfortunately. The starting angle is assumed to be 0, 0. Now we loop through n, 1 to n, and we create the x and y component for the perimeter point. Now I want the radius of the circle, because we're drawing in a 1 by 1 space, to be 0.5. In addition to that, the center of the normalized space is 0.505. That is an origin. I append the point to the array that I had created, and I increment the angle by the angle increment. So now I have an array of perimeter points. Now what I want to do is have 2 nested loops. In other words, I want to connect every point to every point and create a line. And that's what the below loops do. Now that's simply by appending the resulting line to the lines array. Now keep in mind that in this implementation, for each point, each perimeter point, there is a line connecting it to itself. Now an if statement would avoid doing that, but it doesn't really matter. The underlying drawing system is perfectly capable of dealing with that. That's it for rosettes. I'd like to move on to polyspirals. The application renders 4 polyspirals. The polyspiral function is provided an array with 3 floating point numbers. Let's take a look at the simplest one. 3 numbers are passed. There's a distance, there's an angle, and there's an increment to the distance. The drawing starts at the center, and what happens is a line is drawn at a particular distance, an angle is turned, and the next line is drawn at the current line's length plus the increment. Now, since the angle in this particular case is 90 degrees, the diagram is much simpler. You'll see it start at the center and continue on out and end at the upper right-hand side. The algorithm is built on top of something referred to as turtle graphics. We're going to talk about that next. In turtle graphics, there's a start point. The turtle moves a certain distance and makes a turn, a certain number of degrees. Moves another distance and makes another turn. Eventually, there's a stop point. What you end up with is something referred to as a polyline. Now, as a side note, which has nothing to do with polyspirals, if you connect the end point to the start point, you end up with a polygon. It's perfectly okay for the lines to cross. That's a general polygon. The ones you're used to are simple polygons. For example, a parallelogram. The ones like equilateral triangles and squares are actually regular polygons. Let's move on and take a look at a turtle function. To implement the turtle functionality, there needs to be the concept of the current position and the current angle of travel. What is provided to the function is the length and angle for the next segment. The new angle can be easily calculated by simply subtracting the turn angle from the current angle. Now I say subtraction because I'm assuming that the angle provided is a right-hand turn. There's a conversion factor to radians, which is used in the sine and cosine function. The calculation of x and y is relatively trivial, and you want to add that to the current position. So you have a new point. You want to append a line, which is a line from the current position to the new position, and you want to update the current point and the current angle. Now, for people that are deeply into this programming language, they may wonder why I'm using class rather than struct. The reason is that Swift does not allow code within structures to modify its containing data, which I think is probably an artifact of the automatically generated initializers. So it's a class, even though I'm not using inheritance whatsoever. Let's move on to the higher level function. The polyspiral functionality makes use of the turtle functionality. The function gets three parameters. It gets a distance, it gets an angle, and it gets an increment to the distance. I copy the distance parameter because the Swift language does not allow you to modify the argument value. I instantiate a turtle object and I modify its parameters. I put the turtle at the origin and I start with an angle of 0. I don't make any assumptions about the initialized value of the turtle object when it's created. I loop through 100 times, 100 lines will be created, and I invoke the next line function on the turtle saying certain length of distance and a turn angle. And then I update the distance variable by saying distance plus increment. Now, where does the 100 come from? If that number is too large, the diagram will grow. It'll grow to the number of lines. It'll just get bigger. Now, the real key to the diagram is the angle and the ratio between the distance parameter and the increment. If you keep that angle constant and you maintain the ratio to be the same, you can play games with the number of lines. It's something to experiment. I'm going to stop here, and in the next video, I'm going to go on to the rotation functionality in the application.